Yeah, what's up, everyone? I don't know. What is up? Sorry, I realize I probably say that every time. Hey, what's up? You're like, I don't know. Your video. What am I supposed to say? Oh, nothing much. Back to the computer. True. Anyway, I hope we're all doing great. We're going to continue this fun exploration of converting units of measurement. I'm going to try to just get into it. Today is our mixer event. Yeah, it's like the big event. Woo, these are my streamers. They kind of look like um what? Is that how they go? Like streamers, confetti, whatever. They look like weird question marks now. Anyway, but meaning this that like it's not really about a specific unit of measurement today. It is about them all. So it is about understanding that in that mixer of different things, like what do we know? How do we get the information? And then how do we follow that system of converting? And so the point of this one today is those steps. So let's just dive into it. I'm not going to break down all my words. I know I'm not doing it today. Nope, can't make me. Can't make me. I'm not going to do it. You already know. If you watch the other videos, you already know. If you didn't watch the other videos, go back and watch me break down all the words. Anyway. So yeah, so the steps today, right? So just remembering, again, it's that same thing. We got to build that T chart. That's where we're going to start. We're going to build that T chart, and then we're going to focus on the 1-to-many ratio. And again, that doesn't make sense yet because the first time you watch this video, don't worry, I'll still talk about it when I model it. And then step 2, right? We are going to find our rule. Now, remember again, in converting units of measurement, our rule is a ratio, and in these ratios, we're really only going to be focusing on multiplication or division. So it's just deciding on whatever that conversion rate is. So that's a cool thing about that rule. And then step 3 is when we actually do the solving, we solve for the unknown. It's crazy if you think about it. It's step 3 where we actually do the problem, the work. Steps 1 and 2 are all preparation. It's all the mathematical thinking. So, again, just remembering that. Okay, cool. Let's dive into some mixer problems, like whatever. We don't know what we're going to get today. Ooh, the drama, the suspense. What units will we convert today? Well, let me tell you. What? That was weird. Okay, so let's go ahead and start today with 7 feet. And there is an wanting to know how many inches would we have in that process. So again, mixer style, we just need to break down what we know. Step 1, go back to our steps. Boom! Step 1, make a T-chart, right? And find the one-to-many. So let's do that. Let's go ahead and start with our T-chart. Again, I always like when I'm doing like the units, I just work left or right with what I have. So I see feet. So I'm going to start with feet here and then inches here. So there's my T chart because it's talking about the units of measurement I have. And then I need to set up that one-to-many. So again, remember, I'm not even paying attention to the 7 feet and the blank inches yet. I'm only thinking feet and inches. And then I'm thinking, what is that conversion rate? What is the rule of always? And the rule of always then is that it's 1 foot is then 12 inches. Those are equivalent. So for every 1 foot, we have 12 inches. Now, from there, when we go to step 2, that's making the rule. And the T chart helps you make the rule. That's the cool part because the rule is stating to me that if I take feet, right, and I'm going to inches, so I'm going from the number 1 to the number 12, so that I'm increasing. I wouldn't say I'm increasing in value, I'm just increasing in numbers, right? And so if we look over here at what we're talking about with our rules, right? We know that we're either multiplying or dividing. So if I go back to the work and I see that I'm going from 1 to 12, then that tells me that I am multiplying, right? I'm going to get larger. I'm going to take my feet and then I multiply it by 12, and that's going to get me my inches. So this is the rule, right? Feet times 12 equals inches, which is true. We see this right here because 1 times 12 is equal to 12. That's the rule. That's the conversion. So now this is where we do that step 3 and we solve for the unknown. And what I'm going to do is this is what we know. We know we have 7 feet. So I'm going to come to my T chart and I'm going to put 7 in the feet column. What I don't know is how many inches that is. But what's great about that is I have a formula right here that tells me the answer. because what this is telling me is that I'm going to substitute and then solve. I'm going to substitute this variable of f for feet with a 7 because that's what I have. I have 7 feet, right? Look, these are feet. Here's a 7. It's a t-chart. I have it. So I'll just supplement 7 times 12. And that is ultimately going to give me my inches answer. So I don't know. I'm going to come over here and do that math. I don't know 7 times 12 off the top of my head. But I do know that 7 times 2 is 14 and that 7 times 10 is 70. So that'd be 84. So I get 84 inches as my answer. So there it is, right? Again, this mixer today, that was just feet in inches, but look at the strategy. T-chart, one to many, make the rule, solve for the unknown. Yeah, I hope you can hear me making my point with every word. I don't know. That's just me slapping my hands. That's not like that's it. I don't know why I had to be dramatic that way. Okay, cool. So let's move on. Mixer time. What do we got next? That was feet and inches. What are they gonna ask of us next? The suspense and the drama. I guess. I'm sure you're all like, ooh, what is it going to be? I don't know. Let's try. Ooh, let's go here. Let's go. I like this because this is where it's like at first you're like, what, dude? No decimals, blah. But actually, it all works. Let's say we have 1500ths of a liter, and we are very curious how many milliliters we have. So again, we just use the process in this mixer. It doesn't matter. I did inches to feet. Let's do liters to milliliters. It could be quarts to pints, cups to ounces, yards to feet. Wait, did I already say that? Tons to pounds, whatever, right? Mixer doesn't matter. But we're going to still make a T-chart. And I'm going to start again with what I have. And I have liters here and milliliters here. And then we have to think about our one-to-many rule. And so here's a few things. One, we're not always expected to know all of our rules. If you work with me in person, I've made that sheet for you that has our units of conversion, so that you can always check that. If you've ever do your math in a composition notebook, the back cover of a composition notebook actually has all these units of conversion, and it has the rules. And you also could just Google it to find out, right? So it's not always about memorizing them all. Sometimes we have to go back to our resources and check. There are some that are in our head. 12 inches is a foot, 3 feet is a yard, 4 quarts makes a gallon. There's some things that I think we should just have, but yeah, like liters and milliliters, maybe we don't know that one, but we do, because what we do know is that 1 liter is equal to 1,000 milliliters. Okay, so now when thinking about the rule itself, again, I'm starting with L for liters, and I'm going from 1 to 1,000. So that number is it's getting larger, so that must mean I'm multiplying. And then again, because it's 1, the identity property of multiplication states this has got to be 1,000, and that's going to equal my milliliters. So really, I'm just multiplying my liters times 1,000 to get any amount of milliliters. That's what's so great about this metric system. It's a base 10 system, right? Like, thank you. What a great idea. I don't know why we all don't use this. It makes a lot of sense. So with that being said, we're going to go solve for the unknown. So what I do know is that I have 1500ths of a liter. Promise that says 1500ths. Ooh, that looks rough. And I'm trying to figure out my milliliters. So again, this is substitution. I'm just going to take this 1500ths. I'm going to substitute it for this L. So 1500ths times 1,000. And that's going to get us the answer we're looking for. Now, again, this is base 10. So the cool thing about that is that I don't actually have to take 1500ths and multiply it by 1,000. I don't have to do like a area model multiplication, because with base 10, I know that I have a 1. Oh, I'm going to use a different color so this pops out. Sorry, hold on. I know I have a 1 here, and I'm multiplying it by these digits. Well, 1 times any digit is that same digit. So I'm still going to have a 1 and a 5 in it. The only reality is my digits don't change. It's the place values that change, because we are multiplying something 1,000 times larger. And 1,000 has 3 0 place values in it, which means that my number, my digits in 1500ths are actually going to increase by 3 place values. I'm gonna get rid of this arrow because I'm gonna do this work over here. This is that base 10 multiplication. And if you're like, I don't know what you're talking about, guess what? I have videos on that. So you can go back and watch base 10 multiplication and base 10 division. It would be a really helpful tool. But with that being said, let's just model that. Let's think about what this means. This means I'm getting 3 digits large or 3 place values larger. So my 5 is actually going to move up 3 place values. So there's 1 place value. There's 2 place values. There's 3 place values. That actually means my 5 is moved all the way to the tens place. And then from there, we could continue, right? 1, 2, 3. From there, we're going to take this 1 and we're going to do the same thing. So this 1 is going to do the same thing. It's going to move 1, 2, 3, and it's going to end up in the hundreds place. And then I don't have to move this 0. The 0 is already there. And these digits no longer are there because I moved them, which means I now have a new value. And if you look at this number, it's a 1 in the hundreds place, a 5 in the tens place, a 0 in the ones place, a decimal with no decimals after it anymore. So I actually don't even need that decimal anymore. And I have a whole number. It's 150. And that would be my answer, that 15 hundredths of a liter is the same thing as 150 milliliters. Dope. I love this. Mixer day is fun. Look at us. We're just doing all sorts of different conversions, but we're using the same strategy, right? T-chart, rule, or one to many, rule, and then solve for the unknown. So let's put this to one last piece here. And in this mixer, it's going to get even mixier. Yeah, I said it, mixier. I don't even know what that means, but it's more mixing. And let's do this. Let's break it down. We actually are going to dive into a word problem. And here it is. Here's our problem. A whale, right? A big old whale weighs, swear that's a W, weighs 5,000 pounds. Period. An adult elephant. I don't know. I don't know about the whale. Maybe it's a baby whale. I don't know what kind of whale. Beluga whale. And, killer whale or an orca, I guess would be the right name for that. Whatever. But an adult elephant, I guess this doesn't matter. Weighs 3 tons. Okay. Which animal, this is the question now, which animal weighs the most? Okay. Well, we are now in that place where, and I love these. I love these because we're talking about, this is still conversion because we have 2 different units of measurement and we can't really compare them if they're this different. But I am thinking here, we're literally at like this concept of we have 5,000 and then we have 3 tons. Oh, I guess I forgot the pounds over here. Hold on. So pounds. And we're really thinking like, what is the correct symbol? Is 5,000 greater than 3 tons? Is it equal to 3 tons or is it less than 3 tons? So this is kind of the math that we're doing in this. But again, to do this, it's still T-chart kind of work. We just have to decide what we want to do. To compare these units of measurement, I either want to make everything in pounds or I want to make everything in tons, right? So if I turn 5,000 pounds into tons, then I can see how many tons that is and compare it to 3 tons and say what's bigger. Or I can take my 3 tons, convert it into pounds and compare it to 5,000 pounds and see which one's bigger. So in order to do that, I'm going to jump to the next page actually and start with that T-chart because that one to many would probably be very helpful. So let's go T-chart. And then, oh, wait, let's go back real quick because pounds. Okay, so we're going to go, we're not going to go there. We're going to use the marker, the marker. We're going to go P for pounds and then T for tons. And then my one to many is that actually the tons is the 1 unit and there are 2,000 pounds in a ton. So if we think about what this rule is, I have P as in pounds, divided by, because we are getting to a smaller number, not value, but just a smaller number. P divided by 2,000 would equal the number of tons I have. Okay. So then let's go back. And I guess if you wanted to, I mean, inverse, I don't even know why I didn't think I love that. I mean, think about the inverse would just say that tons times 2000 would equal the pounds. So that's another way to think too, like using that inverse in our knowledge of numbers. And let's just play around. Let's just see what would make more sense. Let's go back to this problem and say, would it make more sense to take 5,000 and divide it by 2,000, or would it make more sense to take 3 tons and multiply it by 2,000? I'm a fan of multiplication, because I think if I can just multiply, in most cases, we have whole numbers when we multiply. In most, not all cases, but in most cases, we have a higher chance of having like a fractional part or leftovers or remainders or whatever you want to call it when dividing. So I'm a fan. If I can use multiplication to convert, I'm going to. We could do it either way, but let's go ahead and multiply, which means if we're going to multiply, we're going to start with tons and we're going to go to pounds. So according to our problem, what we have is 3 tons. So if I substitute that, that's a 3 times a 2000, which would be base 10. I love that. 2 times 3 equals a 6. And then 1, 2, 3, 1, 2, 3. So I end up with 6,000 pounds. So 3 tons is 6,000 pounds. So let's go back over here, and in place of these 3 tons, I'm not going to cross it out. I'm just going to write above. Whoa. Huh. Apparently, I'm not going to do that. I'm just going to write above it 6,000 pounds. And now we can just look and say, like, what would make sense? Let's get this out of here and think about what symbol we would put in there, what equality goes in there. I have 5,000 on this side. I have 6,000 on this side. That actually means then my greatest value, my higher value is the 3 tons. So if we were to read that, we actually remember read it left to right. We're not saying 3 tons is greater than 5,000. This sentence here says 5,000 pounds is less than 3 tons. And that's it. We did it. That's it. We're done. That's it. Maybe the longest, shortest video. Who knows? I don't even know how long this has been going, but I feel like I did a really quick one today. And you know me, I love doing long ones. I talk forever. So that's it. Think about it again. Mixer style. I hope the point and what you get out of this today is that it doesn't matter our units of measurement. What matters is having the system. And if we have a system like building a T-chart, finding the one-to-many, establishing our rule, and then solving for the unknown, you're going to get it every time. It shouldn't change. It shouldn't change what unit of measurements you're converting. That's why mixer was the theme today. So that's it. I'm done. I'm going to sign off. You rock. Keep up the good work, and we'll catch you next time.